How's everyone feel? It's the end of the day. Got energy still? Okay, good. So I have an hour apparently, but maybe if it goes a little shorter, it's time for questions. The basic goal here is to really give you guys a good sort of understanding for like what is this Atlas product that you've been kind of given by your bosses, how you can use it, what situation should you use it, what situation shouldn't you use it, what kind of capabilities does it give you, and I'll give you guys a little bit of a tour of some of the things that's now possible to work on. So again, at its core, figure out and kind of educate you guys on how to get anyone to work on able to work with Atlas. Concretely, Atlas is a tool for working with small and massive unstructured data sets. Unstructured data is the kind of thing that wouldn't fit in an Excel cell. So lots of text, images, video, audio, data that has the kind of shape that goes into and out of modern day generative AI systems. Atlas is sort of the kind of like the successor to Excel in some senses for working with data of this sort of shape and form. Kind of at its core, I'll talk a little bit about Nomic, who we are, why we're partnering. I'll talk a little bit about the emerging generative AI stack. This might be something that, we've had a lot of conversations around sort of applications of generative AI systems, things like recall, things about sort of like the consequences of these systems being deployed into the real world. But how are these systems built? What are the engineering components that goes into these things? I'll touch on this a little bit and talk about how Atlas fits into that and how some of your teams internally, specifically the generative AI team, are kind of adopting these tools. Talk about the platform. I'll go kind of nitty gritty into all the sort of capabilities that it has, because hopefully it'll shoot some pulses through your brains, and you'll realize, oh, I can use this in some project I have internally, and you really leverage this sort of the license you guys have to the product. Talk a little bit about our partnership and the ways you can go about getting access to the product, and then I'll give you a sneak peek into our internal 2024 roadmap and the kinds of stuff you guys will be seeing emerge in Atlas over the next year. Yeah, so at its core, I flew a long time to get here. So we're based in New York, in the Flatiron. We're next to that big, beautiful building you might see on TV. So we're Nomic. We're a company focused on building accessible and explainable AI systems. So how do we make sure that this kind of innovations in generative AI and artificial intelligence in general are sort of democratized and access to everyone? We build products that sort of enable that. We also really care deeply about interpretability of these systems. How do we make sure that the biases that propagate from the data sets powering generative AI systems, don't have mal consequences on the world? So my background is actually a PhD student at NYU before starting Nomic, working in like interpretable machine learning systems. So I have a lot to say. Maybe not all of it's important, but I have a lot to say about that stuff. And yeah, some of the products that we built, we kind of build this product called GPT for All, which is an open source app that runs large language models locally. You guys might have heard of it, interacted with it. And then also we built Atlas alongside training our own machine learning models that power the product. We're very vertically integrated in the sense that we make our own machine learning models, we build products over top of them, and we're very opinionated on how the world should interact with the data sets that go into them. So the emerging generative AI stack. You might have interacted with a lot of these chatbots out there. The release OpenAI had this morning with their sort of multi-modal model that outputs audio. At its core, sort of like the way you build these systems is really you start at the data. The most important, most critical part of these AI systems, like large language models, and I'll use that term to refer to like the multimodal versions of these things as well. They're all sort of compressed versions of these giant data sets that they've been trained on. And when I say giant data sets, I mean snapshots of the entire internet, of the images in the internet, of the audio that you might be able to generate from the internet. OpenAI, in training their language models, took all of YouTube, transcribed it, and trained the models over top of it. Anything that these models can do, everything they're capable of doing, everything they're not capable of doing, is a function of the data they've been trained on. The way you sort of program these models and their capabilities is you go in and you adjust the training data set. You figure out what subsample of that data, where the whole sample is the whole internet, should go in to make those models act in what kind of manners that you want them to act in. Alignment training at the end sort of drives the biases of these models as well. And as you can see here, it's not just me saying this. Companies in the world find data to be one of the most important, most critical things. Reddit is inking deals with companies like OpenAI for exclusive access. Stack Overflow has an exclusive deal with OpenAI right now that is actually causing lots of internal strife where people are going in and deleting their old Stack Overflow posts because they don't want them in the training data of OpenAI's models. Data is the gold here. And you guys are also sitting on a gold mine of data from all of the various sort of engineering sources that you're on. And Atlas is the product that helps you work with that. But at its core, you have these language models, which may be something that you've interacted with and you've played with when you open up OpenAI. There's also other models that kind of go into the stack here. Some of these models called embedding models. If you use these systems, you might not have heard about these. But if you're an engineer working on building these systems, especially in a generative AI team, You know these models very near and dear to your heart. Embedding models allow for sort of large language models to be customized to the data sets that are kind of like domain specific. So for instance, ChatGPT might not be an expert in Australian policies on building bridges. You guys have data sets that, might define some of those policies. How do you make sure that ChatGPT instance can interact with that data set? Well, you use an embedding model to sort of inform it. And, all of these models and the way they're trained and the way they interact with and the kinds of results that they produce are all functions of the data that's gone into them. So how do you make sure that data, is the data that you want those models to be being shown? And honestly, the kind of questions that we see from a lot of our customers, and I'm sure have been really deeply kind of ingrained into a lot of the thinking that's happening here at Oricon is just what can we even do with generative AI, right? It's, building a chat with your PDF app is great and all, but there must be more promise, right? There must be more things that can be built with this technology that isn't just chatting with data sets. And it all starts with the data. What data do we have? Where is this data sitting? Is it locked up in SharePoint and Google Drive and accessible to any of the engineers that want to build with it? Or, is that data in a place where people can go in and use it in a manner that, allows quick iteration and building of capabilities? How do you make sure that, at an organization with 6,500 people, everyone has the ability to go in and with the data sets that they are allowed to have access to, can quickly iterate, can quickly do quality assurance, can quickly make sure that the right domain experts are working with those data sets. Can we be sure that the right domain experts are seeing the data sets they're supposed to be seeing and in that process tightly? Because, machine learning engineers, data scientists, they might be the experts in the computational stack, but they might not be the domain experts for the actual data sets they're working with. That creates a really, really bad loop of back and forth data flying around. You want to make sure that the people who are experts with the data are the ones to be able to work with it and do the actions on the data that you need to kind of develop and build these systems. And then sort of finally, this is kind of really good coming off after this talk that we just saw, right? Ultimately, any product that you build that's powered by any sort of generative AI system that you build that's powered by the data sets that you guys have is going to embroil and have within it the biases that those data sets have. And I'll be showing lots of demos after this. So I promise you, by the way, this is a talk full of demos and a talk full of slides. This is the end of it. It has the biases that are present in those data sets. If you never teach your model about bridges, it'll never give a good response about bridges. And how do you detect that before the model gets deployed? Just having a small data set of evaluations that give you a number like accuracy doesn't fully capture the distribution of all possible outputs your model can produce. How do you be confident that you're not going to be shipping out something that is really good for one set of humans using the system, but is really poor for another set of humans? All of this boils down to spending a lot of time with the data. And thankfully, that's what we do. And thankfully, that's what we do. We make it really easy for anyone to spend a lot of time with the data with our Atlas product. But it's been really great sort of seeing sort of the pilot go through to Oricon and seeing the adoption of the platform internally. Kind of at its core, we work with a lot of customers all around the world, kind of bringing on this new age of being able to allow people to really seamlessly work with types of data sets that go into generative AI systems. Previously, you had this giant mishmash of data engineers and data scientists and security teams and companies and, domain experts that actually knew what the heck was going on with that data and people who were actually building the models, all sort of passing stuff back and forth and trying to figure out how to go in and build the thing that they're trying to achieve. And then once you have that first version of the model or have that first version of the system, you have to then go in and keep iterating on it. With Atlas, we basically sort of really simplify this data process work by making sure that everyone has access to the data, the kinds of the shape of data that goes into these systems in a manner that's collaborative, in a manner that allows anyone to take action on that data. You shouldn't have to be a machine learning engineer or a data scientist to do the kind of work that requires to sort of curate and make sure that the data that you want that goes into your model is high quality. At its core, that's kind of what we do. We make this world-class data interface that allows anyone to work with this data. You guys have access to it. And then there's everything you can do. That interface is programmatic as well, so it's production ready for use of any sort of client-facing deployments. One thing I'll kind of add here is, there's all these fancy engineering terms that can be thrown around. I'm not going to get nitty-gritty there, but I do want everyone to know, especially people here who kind of stand at sort of the forward-facing, client-facing projects. This is a production-ready application. There's kind of engineering guarantees around sort of data storage in it, the kinds of things you're capable of doing with that data, how data changes, how data sets evolve in this system. And most importantly, most importantly, that this is a system that's accessible to non-engineers. It's designed for subject matter experts to be able to get down and dirty with the data sets that you guys have kind of being ingested. So we work with customers like some of the larger customers, SmartDirect, we work with Grammarly, AstraZeneca. Most excitingly, we work with you guys now. So, all right, that's enough talking. I'm going to fly you guys around this revolutionary data interface that you guys have access to. So I'm going to go kind of step by step to make sure that everyone here knows, number one, the set of tools that you have access to, the kind of operations you can do on large data sets of text, images, video, audio that you guys have access to now at Oricon. And I will maybe at some points, I'll be doing things that maybe seem a little bit repetitive or redundant, but there's a point to it. The whole point is that I want a light to go off in your brains when you're like, hey, I have data of this modality that I can now use in the system. I can expose it to people internally and make it available for building any sort of system that needs to be built. So at its core, what I'll do is I'll start out and I'll just drop a data set into the system. So I'll be using the sort of publicly facing version of our product in this demo. You guys have an internal kind of like single isolated instance for your whole company. I'll go at the end how to use that and get access to it. I know many people in this room have actually already been using the pilot version of it. It's been great talking to you guys the past couple of days. But let's get into it. So at its core, Atlas is a product where you can drop in data sets. So I'll go in and I'll log into Atlas. And I'll go in and I'll upload a data set. And then while the data set's processing, what'll happen is I'll jump into a demo. So I go in, that's just a CSV file. So at its core, Atlas operates on tabular data sets. That's the kinds of things you maybe see in Excel, or if you know the words parquet or arrow mean. This is a data set specifically of news documents. So it's 3 columns, an ID, a label, which is actually like a classifier label for the news, and then the actual raw text of the news. Now the power here is that you can actually work with this text data really easily that comes in this text column. So I'll call this news example. Say I want to organize it by the text. You'll see this is multi-modal, so you have images, you have videos, works the same. And do a couple things here. Hit upload. And should be ready to go there after it uploads. This is going to be a data set of 25,000 news articles. It might be a data set of 25,000 excerpts or extractions of PDFs, for example, like you might have in SharePoint. So while this goes, I'll pull up this data set that we have kind of prepared that kind of exemplifies, I think, some of the kind of core differentiators and capabilities that you kind of have over data sets. So what is this thing you're looking at, this big point cloud? This is the data set viewer that sits over top of the data set that you have stored in Atlas. The way you interpret this interface is that every single point is a kind of like a row you'd have in your Excel file or a row that you have in your data set. And then 2 points are close together if the data columns are talking about the same thing. So whether the rows are talking about the same thing. So in this case, this is a data set of humans in Wikipedia. So every Wikipedia article that's talking about a person, and all the Wikipedia articles that are talking about basketball players all get grouped together semantically here. This is the power of Atlas. It allows you to semantically fly through data sets that are unstructured: text, image, video, audio. Notice here some properties of this data interface. It's scalable. This is this is kind of small. It's 1.4 million Wikipedia articles. And you can see it all on one screen. You can fly around this data set. Maybe I can go in and zoom in here and look at all of these people that are, well, maybe that's a bad example. People here who are Vietnamese politicians. Any column that you have on your data set, you can go in and slice and dice by it. So for example, what you're seeing here in the colors, these are actually automatically extracted hierarchical topics from your data set. So we can find themes in your data set that exist in a textual data set that exist. So for instance, this was like comments from like user reviews or something like this. You'd see all the positive comments have a theme of being positive things and negative, so on and so forth. I can go in and slice and dice by columns. So maybe I can go in and color by, let's say, the gender of the human that exists. Notice here you get this kind of weird property where everyone who's of the same gender, in this case I think these are females, all get kind of grouped together in this interface. This is because the way this data set is processed is because you have an AI model that runs and does this organization. That AI model can be Nomics, or it can be sort of Oricon's AI model, this embedding model. And the reason you're seeing all the men and all the women kind of grouped together is because there might be biases instilled in that AI model that are then represented in this interface. So for the engineers here, what you're seeing here is you're seeing the embedding space of that data column represented in this 2D interface. And any biases that might be present in that model that generates the embeddings get reflected here. So does your data set have bias? Well, you got to be able to look at it to be able to determine that. We make that really, really easy. one of the beautiful properties that you get in Atlas is that, you have this view here that cross-correlates semantic information. So things that are similar get grouped together. But you can inject, let's say, additional views. So suppose I wanted to, I had the information about the longitude and latitude of the birthplace location of all these people. I can go in and organize by that. And you'll see the data set can go in and transition to a map of where every single person was born. So where are we in the world right now? We're in Melbourne. There you go. Okay. So if I go in and fly into Melbourne here, I can just go in and then create a semantic lasso. I can select that general Melbourne region of that data set. And now I've selected every single person who has a prominent enough Wikipedia article to have an entry in this data set who was born in Melbourne. You guys want to know where they died? Boom. Well, I wonder. Let's see. The ones that died in LA. Oh, come on. This is like capability number 1, guys. So I can go in here and pick all the ones that died in LA. And one might ask, if you're born in Melbourne and you died in LA, what did you do? Probably you're an actor or something like this. That might be a thing that you are. Yes, stage and screen actress. I can double check that. I can go in and cross correlate that with a semantic view and see where you end up. And in this case, kind of scattered around the world, but people in filmography and so on and so forth. One thing I also might be interested in is saying, who are all the football players born in Melbourne? Let me go in and select Melbourne again. Should make this transition faster. And then I could quickly go in, and out of those folks, is that Tasmania down there? Thank you. Yeah. I can then go in and filter for everyone who's a football player. And what this will do is it'll combine these filters together. So the core way you go around, kind of like a Photoshop-like view onto your data set, the core way you want to navigate your data sets is you always select you build some object called a selection. And this selection here, for example, is one that takes everyone who is geographically born in Melbourne and also cross-correlates that with anyone who mentions the word football in their Wikipedia bio. Yeah. Clicking. Mentions football in their Wikipedia bio. And what this allows you to do is, yep, there we go. Oh, a lot of them apparently mention football. It went through the first time. So it seems like that's all you guys are famous for. But I can check here, so I can go in and go back to that projection view, and you'll see here that, oh yes, in fact, yes, they are all football players. So anyways, the whole idea here is that data sets are not single dimensional and they're not just tabular data sets. You can go in and do all these types of cross-correlation informative views onto that data very, very easily with a tool that lets you interact with high-dimensional signals like Atlas. So I've showed you guys multi-positional views. I've showed you guys the ability to go in and draw semantic lassos. So for instance, football players might be of interest. Let's select all the football players in the world. And they're football players because they're in this region. And then I can go and see where they were all born. So this is just sort of kind of flying around that you can do. Now, another really, really powerful capability of Atlas is that it allows you to interrogate your data semantically. So when you look at your data set through this 2D semantic view, what you get is things that are close together semantically, so that the documents are talking about the same thing, they're similar to each other. But then I can also kind of insert my own queries, right? So I can go in and ask. So this is this neural search capability. It's another way of doing a filter over top of your data set that's really novel that you won't have access to anywhere else. I could then go in and ask a question, and that question is going to be able to go in and, for those who are engineers here, you're doing an embedding search over top of the embeddings that are stored in Atlas of the data set, and allows you to go in and semantically surface answers to your query. So I might ask here, who is the top football player in Melbourne? Yeah. And what you'll see here is that I won't immediately get an answer, but I'll show you why. So I go in, and what this is doing something called a vector search. If you guys have heard of a vector database, Atlas on the columns for your data set allows you to do vector search and vector search capabilities across pretty large data sets, the kind that you'd be, for instance, be powering recall, for example. And what you're seeing here is usually vector search, what it does is it allows you to say, hey, for my question, what are the top 10 contenders for an answer? Well, that's cool, and we'll give you all the contenders, and you can then filter by distance to be able to select the kind of things you'd care about. This is first and foremost a tool for understanding and acting on your data, And then whatever you want to build should be a follow-up and a final conclusion to your understanding and your action on your data. So I'll go in and I'll filter here by distance, and I'll pick the ones that are in the top. So these are the top matches in my embedding model. So these are the top matches of my vector search operation that I just ran. So as you can see here, these are documents of bios in Wikipedia that answer my question. I can click through them. And for those here who are, have built a retrieval augmented generation system and a large language model that's customized to a domain-specific data set, you'll realize this is actually what's happening in that system. What happens is that your large language model does not know how to answer queries on your domain-specific data set, but what it does know is if you give it examples of sources that it should pull from, it's able to hallucinate less when it actually happens and acts on that data. So Atlas, in this case, is actually allowing you to debug that system and seeing, hey, in the case of if somebody was able to ask my language model that was conditioned on this data set, who is a top football player in Melbourne, these are the results that it would get. And then you can then go in and see like, hey, if that's not the case, maybe I want to adjust and iterate on this data set to make sure that the right results get produced back out. Or maybe I want to switch the underlying sort of like machine learning or embedding system that is powering that model because it's insufficient in capability. So it allows you to quickly iterate and debug, on the data sets that power those end ML systems, like recall, for example. So yeah, these vector search capabilities, this is actually something I'm quite excited of and quite proud of. This is the kind of thing that on the engineering side, we're one of the few companies in the world that support this sort of capability. One other thing to add is, you have a column in your data set, and you should be able to filter by it. So I can go in here and say, hey, let's filter by the birth date of these folks. And it goes negative because 0, and then you have BC. And what you can do here is you can see when were Wikipedia articles about various people. And so this column is just basically a column in the data set. Where were they born? You can see how semantically different types of people were introduced that exist in Wikipedia kind of come into general themes of birthplace. So, of a birth year, rather. So there's a bunch of articles about folks being born in the Roman Empire. These are probably philosophers and all of this. And then more recently, obviously, there's been a lot more humans that have Wikipedia articles about them, if I scroll in that. So any sort of filter you want to be able to cross-correlate on your data set and then figure out, hey, how do I get my next version of the data set? That's what you can do. Also, you can just very easily, export all of these if you want it out into another Excel file and keep iterating and keep moving forward. So those are kind of some of the highlights, these sort of filter tools, ways of building selections of your data set. I have one big data set. I want to select some subset of it. What can I do with it? Well, action is sort of like the kind of key thing that you might want to do downstream of Atlas. You can go in and export the data out, maybe train a classifier over that system if you're trying to map the data set that you have onto some regulatory hierarchy or taxonomy or something like this. Everything that I just did in this interface can also be done programmatically. So your domain expert can be sitting here interrogating your data, figuring out what you need to be able to build and what you need to be able to do, and then immediately be working with an engineer, and the data, it's the same data state that you're working with. All these queries that I'm doing for vector search can be hooked into that production system as well. You should be able to look at your data, no matter how big it is, no matter how weird of a shape it is. Okay. So that was a tour of most of the capabilities in the data interface. I'm not going to dive into code because nobody here wants to stare at API docs, but there's a big documentation section that I'll link to at the end. We covered selections, we covered actions. We covered debugging RAG. The other big thing I didn't cover here, because it requires multiple people, is collaboration. These data set links, and you guys have your own custom domain here at Oricon. You make this data set, and then you want to send it over to Jane over there in the other department. As long as Jane has access to the data set, you can grant her access. She goes in and can do all of these things, pull that data state down, and correct to it programmatically for any application she's building. So collaboration on these data interfaces is key. Capabilities like tagging. So actually, let's see, this data set, oh, there you go, it's built. How long did it take? But way shorter than it took me to get there. So this is about 25,000 data points. I just built this in real time. So this is a data set of news. So every single row here is a news article, and then two rows are close together if the news articles are talking about the same thing. In this case, I can go in and maybe do a search. I can say, who owns Microsoft? Maybe there's an answer here. And then filter down to the closest things in distance. And maybe there's a couple of things around Bill Gates and stuff like this in here. So all of this instantly gets enabled on your data set the second you drag it in or upload it into Atlas. So one of the things I can do here is I can take the data set, send it over to somebody. Most importantly, if I find something interesting in it that maybe I want to use as like a tag or a piece of additional, basically add a column to my data set that I might want to use for some downstream use case. What's really powerful is you can just go do the tagging. So what I can do here is say, these are all the articles about, what happened here? These are all the articles about sports. I can then go in, select them, tag them as sports. And then that tag becomes instantly accessible to anyone else in the organization who has access to that data set. Send over the link, and they can collaboratively build and figure out sort of what are the right sort of like Oricon imposed structure I want to inject on this data set. Okay, so that's kind of a tour of the capabilities. Hopefully some light bulbs will go off in people's heads around, I have data of this shape, I have data of this form. Let me take a look at it in Atlas. Let me figure out how to use this for my internal workflows of my team. I know there's several people here who are heavily using this. They've had a lot of success in sort of their internal workflows. I'll point to them at the end, or you can just come up to me and we'll get you there. I'll have a slide at the end also kind of talking about the kinds of ways to kind of move past this presentation to actually use the product. Maybe this is something just cool to show. One thing I didn't cover is duplicate detection, but I'm not going to get into that. I want to show some of the multimodality aspects of it. This is all of Wikipedia on one screen. Every single Wikipedia article as of November 2011. Basically, the point is we support scale, and Oricon supports scale now. So this is every single Wikipedia article, or kind of organized semantically. You can fly around and see all the different ways tennis is mentioned in Wikipedia, for example. So there's people talking about tennis tournaments.
And tennis. I think what that's it.
Yeah. Seems like newspapers that are mentioning Eurovision or something like this. So the general cluster is Spanish. This is like an auto-imposed hierarchy, so we can identify categories and topics. But there's a whole actually section on Eurovision artists. Maybe there's a tennis player in Eurovision. Let's see. Oh, a couple. For some reason, tennis and Eurovision are co-mentioned in a Wikipedia article. But basically, lots of data, lots of scale, easy to use for somebody who doesn't know how to code. Okay, here's something fun. So I was turning a bunch of text data sets, and text is cool, but turns out all the signals in our world, most of them aren't text. Text is just this way, humans do a really bad job of communicating to each other with winter vagueness. We support multimodal work. I'll talk to you how we support that a little bit at the end. Really good on time here. This is exciting. And this is a data set of TikTok videos. So every single point is a TikTok video, and 2 points are close together if the contents of the TikTok video are similar. This is, for example, would be a column here would be a link to a TikTok URL in the data set. So I can go here and look at, I don't know, maybe this food area of TikTok. This is, what's up?
Oh, I just said one said chicken and cut.
Yeah, so you can go in here and see, for instance, all the TikTok videos that talk about drinks. I think this is in a day sample. All of them go in and kind of group together. And what this allows you to do is really, really easily, have the ability to take action on kind of the forms or shapes of data sets that previously, you couldn't. I then go in and search over this. Maybe I can go in and type tennis. This is actually searching over top of the descriptions of the TikTok videos. And this will give me TikTok videos that match things related to tennis. So any data, any modality, you should be able to fly through that data set with ease. So videos are cool, videos are fun. One data set I really like is a data set of image generations. So this is actually a strong demonstration we usually use in our kind of like engineering demos around when you upload your own custom embeddings. So embeddings are, again, this thing that allows computers to interact with other computers semantically. That's how they represent their data when you're talking about like AI. And here what you're seeing is a map of where every single point is a generation from Stable Diffusion, and then it's just loaded up as a data set in the Atlas product as like a kind of a cool demo. So every point here is an image that's generated from Stable Diffusion, and then the representation of that image, and the representation of that image is an embedding from a machine learning model called CLIP. Now, CLIP is a model that's trained to sort of align text and images such that computers know that this piece of text corresponds to this image. And one really cool thing that you can see here is that these models, because they're trained with text-informed information, if you just train an image model, if you just train a machine learning model on images, it won't know anything about text. So it won't know that, for instance, Elon Musk is a billionaire. It'll just know faces of Elon Musk go next to faces of Elon Musk. One of the cool things, as you can see here, is that the embeddings that come out of this model, since they were trained text-aware, they group all the billionaires together. So in this case, you have the images of Elon Musk next to the images of Jeff Bezos, next to the images Mark Zuckerberg, or I guess who is this? Was this Mark? This was Mark. And all the billionaires are co-located with money. So that is a piece of information that was put into the machine learning model by its training data. It's a bias that was instilled into it. You would never be able to see that bias with some single metric you compute of the machine learning model's quality. That bias becomes instant when you look at it through the eyes of the model over top of its training data set. Atlas lets you view data through the eyes of machine learning models. It lets people at Oricon view data through the eyes of machine learning models. And obviously everything else I was showing you applies here. This is a data set of a couple of our friends. Curate is a really, really cool Canvas image generator app. This is their whole data set of images that we put in here. It was a collaboration we did a couple of years ago. This will be a little technical, but basically, if you have your own embedding models or you train your own machine learning models internally at the company, you can upload those as just columns in the data set. And one of the things that we do at Nomic is we build our own machine learning models, state-of-the-art quality machine learning models, and you can do things like compare how different machine learning models represent data. So for example, OpenAI has their flagship text embedding model called OpenAI Ada. We have a competing product to that, actually, which you guys already have access to and have been using internally. And one thing you could do here is see how OpenAI's model represents data sets. So in this case, this is a data set of like Wikipedia articles. And then compare that for how our model will represent those articles. And this is basically a demonstration of like the quality of the model. But we use Atlas to demonstrate the qualities of machine learning models. So I can switch here, and you can see how the comparison changes between OpenAI and Atlas. Nomic embed. Okay, so back to the boring slides. All right, anyways, so everything you just saw here, it's available site-wide to Oricon. We've been working with you guys for a while to sort of make that possible. You guys got a great IT and security team that fully vetted us. And you guys have, I think there's a couple of buttons that need to be clicked still, but then it gets deployed site-wide. I think it's deployed to a couple hundred people right now. So the way you get access to this thing, and the way you kind of get support, and the way you are able to iterate and really help us make sure that the experience is great internally for the product with you guys, there's a Microsoft Teams support channel. Theodoros will be able to put you on it, but also there will be an email going out from your IT team that will allow you to go on and kind of get signed up and start working with this product internally. The one thing I want to note is you guys have your own single tenant approved instance of Atlas. We've blocked anyone from Oricon out of all of our other environments, but you must use this one. That's the one that's IT approved. But that's the one you also want to use because it has a bunch of bells and whistles that you don't get in the other one that allows you to build things in production. And then if you're a developer, hopefully you still found what I said interesting, but there's developer documentation that allows you to go in and get started there. And then here's the fun part for anyone who here cares about new, shiny, fancy things and is an early adopter of software. We have a roadmap, believe it or not. The generative AI team has seen this roadmap and knows about it. I just wanted to share it with all of you guys because maybe you care about this product progressing and how it evolves in the future. But a native support for storing multimedia, images, audio, video, PDFs, the very same way you can store text and images right now. There's things around fancy engineering terms that you get guarantees about what happens to your data and where it stays there. New capabilities of creating sort of semantic subsets of your data set. So like these things like semantic search or data set search, those all come natively. And there'll be new ones that appear. And selection action capabilities. One that I'm really excited about is, just across a lot of our customers, we've really identified this giant theme that a lot of people are just building classifiers over top of their data sets coming out of Atlas. They're using it as a quick way to bootstrap and improve classifier systems. You should be able to just create that natively in the interface, never have to leave. And magically, well, you guys know a little bit ahead of time, you'll have that capability shipped out to you. And I know a lot of teams internally are actually, but you'll be empowered to do it all a lot quicker. and not have to be an engineer to do it. And then the other big thing is we have lots of GPUs burning in some data center on the West Coast that are training embedding models. And those will be multimodal, image, video, audio, and you always will get access to them too. So as part of our agreement. So yeah, that's about it there. I could talk a little bit about Nomic Embed, talk about how cool the model is, but I think that's probably good there for questions. So questions?
I think you blew everyone's mind, honest, but
Or put them to sleep, who knows?
Hey, Dan from Code. I have a quick question. The semantic map that you were originally showing before, is it possible to change the weightings used on that map so we might be able to draw conclusions that roads and bridges are actually meant to be closer together than they truly are by default, or that sort of functionality?
Yeah, so if you have some way of representing sort of like edges, you can go in and use that information. But at its core, the way the system operates is that every single column in your data set has this sort of like neural network enhanced view over top of it by having an embedding sitting there. And the structure in that embedding space is what sort of like induces the sort of structure that you see here in 2 dimensions. So we really are, in a true sense, showing you how the AI is able to see the data set in this view and letting you interact with it. If you guys have your own AI models that have maybe a more informed view of this data set, this is sort of our general purpose model that's like competitive with OpenAI's models that we sort of give to you. If you have that, then yes, 100%.
yeah, close.
Hi, I'm Srimal from Data Analytics Oricon. So, really quick question regarding the instance that's made accessible for Oricon.
Yep.
Just thinking, when working with when we're working with client data, for example, that's really cool for internal stuff too. And just thinking ahead, if you were to use it for client data, some clients sort of insist that we, keep the data within this data sovereignty sort of thing. So is that how easy or hard would it be to make that instance sort of be hosted within Australia if we needed to, or that sort of thing?
So number one, it already is hosted within Australia. So we work deeply with your IT team to make it fully capable of servicing all your needs here. When it comes to kind of client-facing things, this is a tool that obviously unlocks a lot of capabilities internally. There's going to be kind of like larger announcements in the future about sort of like a joint partnership to make sure any sort of client of Oricon with the applications you guys are building also have access to some subsets of these capabilities.
Like dance.
It's the what? Yeah, I mean, it is the answer.
Hi, Andrei. Penny Rush. I'm based here in Melbourne, Diversity, Equity, Inclusion Manager. This may be a question for you, but also the wider team and those who are actively using Atlas already. I just, as a lay person, would love an example of how it's currently being applied or used.
Cool. I think there's people in the audience who might be able to give the example on actual data that's real to work on. Yeah, hands. There you go. We don't see the data that goes in, so actually it's kind of hard to answer the question.
So actually I'm going to talk about it tomorrow. I have a Pecha Kucha in the morning. I'll be talking about it, but just on a high level, we have uploaded few data sets like RFIs, client interaction, then bridge standards, different data sets, and we've built an like a front end where you chat with this data set through a user interface, and you're getting exactly what, and you're showing about like getting the summary, getting the top 10 data points, and getting a summarized version of that. So we have built functionalities, and yeah, we can chat about it more in detail later.
The position mode that you've just selected there is obviously something from Wikipedia. But for us, what would be more relevant, well, I'm thinking me actually, commercial analysis of fees and how our teams have structured things like it's any column of data. Is that what it is? So if I'm looking to see whether it's the structural engineer versus the mechanical engineer doing the work, I'll get a visual representation like this. Yep. Or their level of we can define that.
100%. And then you don't have to have some, expert in all of that be able to look at it the second time around.
Yeah. Sorry, Andrew, it's Clive, by the way.
You bring up actually a good point that I forgot to mention. So one of the kind of additions to Atlas that you guys get as part of your deployment is we'll be releasing kind of a vision model. And one really interesting use case in one of our other customers is that they do a lot with like geospatial data. So they have like satellite images or images of, let's say, like from drones over top of some objects. And then those objects also have longitude and latitude coordinates. And then you can go in and, for instance, see this data set map of all those images that the drone has taken, or the satellite images. So for things like all the rivers, they group together, the rivers that have the certain buildings grouped together. You can search over that data set semantically. And then also see how that cross-correlates with like longitudinal, latitudinal locations as well. So if you're doing any sort of machine learning efforts over top of the image data sets like that, this is one of the only products in the world that lets you take that kind of action on it. So I'd actually be very, very interested in hooking up one of our engineers with who's working, somebody internally who's working on that, and having some sort of like customer spotlight or case study or something like that. That'd be really interesting.
Fancy here just said to me, see you later, pivot tables, which, I'm thinking the visual representation of data is really quite powerful. And Scott, you're looking at me too, and I'm thinking, some of the map assessments that we could actually be pumping into this to see trends, to see what we're actually getting out, what we're getting as responses, what are common things we need to deal with.
Yeah, I mean, to be clear, pivot tables are still really, really useful. It's just the kind of shape of data that you'll see a lot nowadays is the kind of data that's unstructured. You wouldn't use a pivot table on it because it wouldn't fit in Excel. And this is one.
But wait, when you're presenting with an order or a group or a management team, visual paper just up a time.
Yep.
Yeah.
Andriy, Tristan from the code team. Just looking at this here, the projection function is really interesting. How flexible is that projection function to, say, start to include not just latitude, longitude, but X, Y, Z types of coordinates?
Yeah. So the projection functions additional columns in the data set. So if you could inject those in, there's additional columns like you have in Excel or something like this. It all operates on, if you're familiar with like data frames or something like this, it's like the same concept. It's just a visual interaction layer over top of it. That's semantic.
Hello again, I'm Alex from Data Analytics team, and I have a question about embedding model. You mentioned that Nomic offers embedding model, and you mentioned about its performance in comparison with, I think, OpenAI model. So, two questions. First one, how many dimensions in Nomic model? Yep. And how it compares with OpenAI. I have previously used OpenAI, and so the older model which you mentioned, I think, has 1.5 thousand, and the newer, there is new available which has 3,000 dimensions. And so, what about Nomic? Yes, thank you.
Sure. So, what is an embedding model? An embedding model lets computers represent data in a form that they can communicate that data. They can communicate that data semantically to another computer. So when you do like a search in Google search, it's doing a search over top of embeddings because it's able to match answers semantically. Like just because you might have the word, I don't know, happy, but other words that display positiveness would get matched too. That's what an embedding model allows you to do. One of our sort of like core capabilities and the things that sort of really differentiates us is that we don't just build applications. We train machine learning models from scratch, and we train the state-of-the-art quality machine learning models from scratch. So we're better than OpenAI across several metrics, and we kind of have this very strong philosophy that machine learning systems should be open source. It's the best way to sort of disseminate, spread, and democratize access to them. Also, our core product is not, building the highest quality model and blocking it behind an API. That some of you can do this. But to answer your question concretely, our models are better than OpenAI in performance. They're completely open source. They support long context, like AK context links. The embedding dimension is actually resizable because of a bunch of machine learning wizardry that we've done. So the default dimension is set to 768, but you can resize it all the way down to 256 or 64 with low losses of performance. You don't have to actually take my word for it. We're one of the top two of our models are one of the top 5 on Hugging Face, which is like this big open source model repository. You guys actually have a production version of that model as part of your Atlas deployment, so you can use that model already. People have been using it already, like Kajal over there. You also don't have to take a bunch of metrics. This is actually the CEO of Snowflake talking about how cool our model is and how they were able to build over top of it to release their model. They have since given us more credit than just saying we built over top of it, because they did very little to build over top of it. And it's been out for like 4 months now. It's one of the top models on Hugging Face in that manner. Also, there's a lot of really cool cost benefits to it. So this is maybe a little bit more nerdy for you guys, but one of the things our model supports is compression. So when since we get to build our machine learning models from scratch, what that means is that we can instill things into the objective that you maybe wouldn't get with like a general purpose model like the older ones from OpenAI. One thing is that we support binary embeddings. What this means is that you can take every single dimension of your embedding vector and you can quantize it to a single bit, compress those bits, so 32 dimensions would be like an N32 object, and then you would lose very little performance in actually doing bitwise XOR and popcat operations for search. So you can get things like saving like 2 orders of magnitude in storage and computational costs while still getting the same sort of vector search capabilities you get with anywhere else. So this is all to say, quality good, cost down. Yeah.
Nice, thank you.
The dozen data engineers were just blown away by that.
Chris from Code. So I'm sort of racking my brains here a little bit because we've talked a lot about tabular data. If we have lots of object data, like arbitrary JSON objects that might have all kinds of different relations or very little overlap, what's the method? How do I need to be thinking about ways of processing that to get it into a way that it will work with the platform?
Yeah, so there's 2 base components that allow you to operate on this kind of like high. So when you say unstructured data, sometimes you mean like high dimensional data. So maybe they represent that data as like a bunch of 3D coordinates making up some sort of like structure. If you're just coming out of some sort of like computational design software, you can either use a neural network off the shelf that would represent that in a manner where things that are similar, structures that are similar would be similarly represented. But frankly, like that's like a tool for its own domain. There's places if you have metadata, right? So if you have like rich textual descriptions about these objects, that would be a column that you can use and analyze in that data set. But for those kind of use cases, unless you have your own AI models that you're training and iterating on, like we have one customer that does a lot of work with automatic digitalization of maps, and they're training a bunch of neural networks on maps to be able to digitalize them better. They use our product to be able to iterate on those neural networks to make them more higher quality. But if your use case is not specifically machine learning there, it becomes really more of a tool that's really powerful for analysis of the metadata around these things. Yep. Quick question regarding the performance benefit you showed in your models, which is performed better than the OpenAI models. Would you attribute that performance to the structure of the algorithm or the way the network, the neural networks are structured, or the data set, right? So it's always a data set. That's like the whole thesis behind our company existing, frankly. The data is the most important aspect that goes into any application you build, any sort of AI system that you build over top of that data. Data is how you program machine learning models. Why is GPT-4 better than other models in the market? Because OpenAI has spent a lot more time and it's given tons of money to scale AI to human generate preference data for this. It's all about the data in these systems. The more data you have, the more data you have in your control, and the cleaner and high quality that data is, the better systems produce out. So hoard the data, hoard the GPUs.
So quick follow-up, is that not all publicly available data, or you're referring to curating the data?
The one big differentiator between our model and OpenAI is we completely open sourced everything. What this means is that you can access all the data. It's about, 50 billion to 100 billion words in the training data set, and it's all completely open source. Like we have several large multinational consulting firms using us as the default recommended model to clients. Databricks runs 10 trillion words a month through our model.
I'm just curious, since you mentioned or showed earlier the data for the TikTok videos. So how does it categorize videos? So I've noticed in TikToks there are videos that contain 2 separate videos, and then the text is still a different one. It kind of like says a different context other than the 2 videos also included. How does it?
Yeah. So the reason you're able to support a bunch of different data modalities in the same sort of experience is because our product does not operate over top of like the raw image pixels or the audio stream or like the words in the text. It generates a neural network representation of that data first, and that neural network representation captures semantics in the video. And that's why it's able to take all the drinks and group them close together, because it's able to activate, there's like a drinks neuron in another neural network that makes all those things represented similar. But at its core, like the underlying data store that you guys get access to if you're an engineer is you can export out all of the neural network representations of all those videos, for example, back into your environment.
On a follow-up question, does it prioritize more of the video or the audio?
In that case, for that embedding model, I don't know the answer to that question. But the thing is that you can go in and use your own embedding model to figure out how that is. I think in that case, it's purely just the video features, if I'm correct. Yeah.
We might pause on questions. I think we're out of time. Sorry. Andrey's here for the next few days, and there's loads of opportunity to pick his brain. I'm sure many of you've got
Please do.
many more questions. And I just watching that, I can imagine loading a whole ton of asset information into this, and imagine what we can do. So thank you again for taking the time to be here today. With that, day one.
I have cool latent space stickers if you guys want a sticker with 100 billion tokens.
Moment, the Nomic stickers are in high demand.
Yeah, I left one of the packs in New York, so you got to find me early.
That's day one. Thank you so much. Today was really about, sort of learning and understanding and seeing what's happening. Tomorrow we get our hands dirty on the tools. And I think that's the exciting part. We've just seen Atlas. Tomorrow you can all experience Atlas. That's the fun part. So with that, we have our community practice dinners tonight. Everyone should have had an invite. Hit your calendar. You should. I think there's 10 or so different dinners. Five different dinners. So smaller groups where you can have really great conversations. Thank you so much for making the time today. Belinda and Alina will be around to get a few more box pops and comments from you all. So please feel free to have a chat, discuss, mingle, and then we'll see you at dinner tonight. Thank you so much.